Hey, Anatomy students, Mr. Yance again. Let's wrap up notes for chapter 10 and 11. Good news is this is the last notes for the first trimester. It's hard to believe. So we're going to be done until third trimester. So we're going to take a break from anatomy and come back and pick up where we left off, hopefully down the road. So I got up on the screen what we went over yesterday. I told you I want to go over it and review it just a little bit. Hopefully you've looked at this video from yesterday and this made sense to you because this is a big 10-point question on the test Tuesday. So you need to make sure you look it over, and you can do it just like this. I just need the steps. Don't need a big flowery big essay. I just need you to tell me what happens. So just a little review. The nerve impulse leaves the brain. That's what triggers all muscle contractions. And when that nerve gets to the end and contacts the muscle, whether it's your arms or legs or face or whatever, that's going to release this really potent chemical called acetylcholine. I think that's the answer to the question for today. So acetylcholine gets released. It's like opening up the floodgates. It just spreads. And then once it contacts the muscle membrane of the fibers, that's called the sarcolemma, that's going to set two things into motion. So two things are going to be set simultaneously in motion. Calcium gets released. It doesn't want to get released, but it gets released from something called the sarcoplasmic reticulum. They're little sacs that contain the calcium. Just like acetylcholine doesn't want to leave their sacs, neither does calcium. You have to force it. The nerve impulse forces acetylcholine out. Acetylcholine forces calcium out. At the same time, ATP gets hydrolyzed, which means that's where our energy is going to come from. So it gets split apart, and we release that energy because energy is never created nor destroyed. And then what's going to happen is we're going to calcium is going to come down and combine with another chemical called troponin, and that's going to basically turn on the actin. Actin's those thin filaments, myosin's the thick ones, and they overlap, and that's what's going to cause them to connect. So we call that a cross bridge. Earlier in notes, I talked about how if myosin and actin are hooked together and muscle contracts, if they're detached, the muscle relaxes. So as long as calcium-bound troponin is there, then the cross bridges are going to form. Over comes that energy that was released from acetylcholine, and it comes over, it slides those myosin and actin filaments to the middle, and your muscle gets shorter and your muscle contracts. So that's pretty much how muscle contraction works in a nutshell. So kind of look that over. If it doesn't make sense to you, shoot me an email and I'll help you try to understand it a little bit better. Hopefully that makes sense. Watch this video. I did post the notes today online, so you can look at all this when you need to as well. All right, 2 more slides and then we'll be done, okay? So muscle tone is another part of this contraction thing. So that whole process I just went through, sometimes it does that all the time in certain muscles just to give you some tone. So even when you're sleeping, we have a small percent of these muscle cells that contract, okay? When you get older or you're in poor health, that reduces the impulses to the muscles, and you see a lot of older people with saggy type of muscles. I'm not being mean, but you see their muscles aren't very tight and toned. When you're younger, you have those impulses flowing and things are good. When you get older, we lose that impulse flow. And then what happens is over time, those muscles degenerate and fibrous tissue takes its place, and you have reduced strength in your muscles. That's why, I've been talking about this in several chapters. That's why it's so important that we emphasize in older people not to sit in your lazy boy and do nothing, because that's going to cause this to get worse quicker. If you're active, you're moving, you're doing stuff, you're keeping those impulses flowing, it will help your cardiovascular and your muscle system both, and your bones. Okay, so all three. All right, last thing, and this is kind of a crazy thing, and there's some great videos you can watch on this too. Okay, so let's talk about some conditions and chemicals that affect muscles. Cholinesterase, I haven't talked about it yet. It's an enzyme that actually breaks apart and kills acetylcholine. So if we need a muscle to relax, we release cholinesterase. It gets rid of the acetylcholine. Everything gets reversed, and the myosin actin detach, and your muscle relaxes. Now, what we found, and this is the crazy thing, and you can see I got tons of videos, and not going to take the time to play them now, but you can watch them. There's even a great one with Ace Ventura, Pet Detective, on there. Nerve gas that we developed during the World Wars, nasty chemical, also called mustard gas. Um, what it does is it actually knocks out cholinesterase. So now think about what that does. So if cholinesterase breaks apart and kills acetylcholine and causes your muscles to relax, nerve gas isn't going to allow it to do that, so your muscles contract and stay contracted. And you breathe in the nerve gas, your throat contracts, your diaphragm contracts, and you literally suffocate within, a few 20, 30 seconds. You're done. So nasty chemical. We've outlawed it and we don't produce it, but there are some terrorist groups and some countries that still make this nerve gas because it's not expensive to make and it's very nasty. So that's what happens with that. Curare, which comes from a poison dart frog, and there's tribes in Africa that dip their arrows in this. It takes a little bit. They rub it on the backs of these frogs and shoot it into their prey. And what it does is it causes the cross bridges not to form. So it's a little different type of situation than nerve gas. What it does is it causes your whole body to relax, and basically your heart just stops. So you go to sleep and you don't wake up. Not as violent as nerve gas, but equally effective, just on a different realm. Okay. Cobra poison and nerve poison, what they do is they cover up the nerve endings, your motor neurons. So where the nerve meets the muscle, cobra poison covers that up. Your muscles don't get that nerve impulse. Acetylcholine doesn't get released, and your heart stops. So pretty much the same effect as curare, just a little bit different cause. Okay, and I don't know what happened to me, but that's okay as long as you can still see me or hear me. Oh, there we go. Okay, last two is nicotine. That mimics acetylcholine, so it causes muscle spasms. So your body thinks acetylcholine is being released, and your muscles contract when our brain doesn't tell them to, and that causes a lot of problems that way. And in severe cases, this would be really severe, like emphysema type of patients. You could get flaccid paralysis where the muscles just quit responding. Okay. The last one is probably one of the more sad types of diseases that are out there. It's called myasthenia gravis, and with it, your basic muscles quit responding slowly. It's a slow type of death. Awful. You lose your functioning in your hands, your arms, your legs, and eventually you die from this disease. And we can't do anything to keep it from progressing. Um, Probably the most well-known person that had this was something called Aristotle Onassis, which at the time was one of the richest men in the world, like a Bill Gates type of guy. And he was famous because he was married to Jackie Onassis Kennedy, so JFK's wife. So she had such a tragic life because she loses her first husband to an assassination, and then she loses this guy to myasthenia gravis. She didn't have a very good life. But this is just an awful disease. And this guy had all the money in the world. He brought in all these experts to try to treat him. And there's the old saying, some things money can't buy, and he couldn't buy him health. So he eventually died from this disease. And it's just a slow, progressive, awful way to go. You just slowly die little by little, and there's just not a whole lot we can do to keep it. And it's a genetic thing. It's not anything that you contract later in life. It's just something that happens. Okay. Watch the videos if you have time. Some of them are crazy good. I got something about snakes, nerve poison. I got the Ace Ventura video clip. I'm not going to take the time to play them here because it echoes so bad on my computer, but hopefully that makes sense. Our test will be Tuesday. I'll have a review game on Monday. So that's already posted. So it's not up and running yet until I do the review game in my class Tuesday or Monday, but it'll be on there for you to look at. Look this stuff over. This is the last test. So please get it in because I'm going to lose track of you guys because the trimester ends. I don't have an anatomy class with you guys until third try. So you need to make sure sometime Tuesday, Wednesday at the latest, I'll send you a password. Get this test done so I can get a grade for you, and I don't have to try and track you down in that second try when I don't have you. All right. Hey, have a good day, and we'll talk to you later. Have a good weekend.